My name is Chaitanya, Physics faculty at Shakthi International School. In this video, we are going to learn about an important topic of class 11 of chapter Simple Harmonic Motion SHM. Okay, we are going to learn a little bit about what is the simple harmonic motion, what is the equation, what is the velocity of the object which is performing SHM, and what is the acceleration. Okay, these are the factors that we are going to learn in this video. So now, simple harmonic motion is a harmonic motion which is very simple. Okay, now let's say we are having a spring. Let's say this spring is in a compressed position. If you are leaving the spring, this is actually the mean position of the object, and this is the extreme position. That means if initially this is the position of the object, this is called mean position. From the mean position, I am disturbing this object by applying a force in inward direction, and finally it is coming to this location. If I am leaving this object, if I am leaving this object here, there is a restoring force that has developed in the spring. The restoring force will push the object in forward direction, okay, which makes this object connected to that spring oscillate in forward and backward motion. That means it will be moving forward in this direction, and this is the direction in which object will be moving, given that this surface is a frictionless surface. Frictionless surface. Okay, now when this object is performing this SHM, simple harmonic motion, this object is experiencing a continuous force. Okay, the reason why this is happening is because the force which is acting on it is always proportional to negative of displacement, which is the restoring force we are talking. We know this from the general formula of Hooke's law, or spring force. Force is equal to minus of kx, where k is the spring constant, spring constant, and x is the displacement of the particle from the mean position. Now, as the displacement is increasing, the force is increasing. As the displacement is decreasing, force is decreasing. If this is the mean position, this is your origin. Now, from this point, it can be going. The maximum amplitude that it can go is taken as plus a, and in the negative extreme, the amplitude can be written as minus a. The velocity of the object at every point will be different. If we are analyzing the equation of force, which is F is equal to minus of kx, in general, force can be written as mass into acceleration, which is equal to minus of k into x. Acceleration can be written as minus of k by m into x. Now, the general equation of SHM can be written as A is equal to minus of omega square x. So that means this is the condition of SHM, where I am writing omega square as a constant k by m. Okay, in place of k by m, I am substituting it as a constant. How we got this? We are actually deriving it from this equation itself. We are going in a backward direction, so acceleration A can be written as minus omega square x. From this equation, if you have written this, if you are solving this equation, you can write acceleration as d square x by dt square, can be written as minus omega square x. The condition of the SHM thus becomes d square x by dt square plus omega square x is equal to 0. This is the condition of object performing simple harmonic motion. If and only if the object, this condition is satisfied, then only it will be a simple harmonic motion. Now, solving this equation, we will be ending up with a final value, okay, final output of x. Since x varies the displacement of the object from mean position. Okay, this is a function of time. This is a function of time. Okay, now if you are writing it, if you are solving this equation, you will be ending up with the final value of x is equal to a sine omega t plus or minus phi. What is this phi? This phi is called initial phase. Initial phase. Okay. What is this omega t plus phi? Omega t plus phi together we call it as total phase. This is your total phase. Okay. That means depending on the position where it is, the displacement of the object is changing. Okay, that if you are analyzing this equation, okay, if you are analyzing this equation, we have seen three different positions of the object. One is mean position, this is negative extreme, and this is positive extreme. The distance from here to here is a, and the distance from here to here is also a, the distance when I am talking. The displacement we are going to substitute it in terms of negative. This is 0 comma 0. That means since it is covering a total of 360 degrees, you can consider the total angle that it is covering in the form of projection. If you are projecting it in downward direction, okay, let's say this is the direction in which I am projecting it. You can take it as one circle in which there is an object here. It is performing circular motion, which is a uniform circular motion. Okay. Now if you are following the shadow of it, if you are following the shadow of it by giving a torch light from here, okay, if you are providing a torch light from here, if you are following the shadow of this uniform object which is performing uniform circular motion, you will see it moving in this direction. This is the direction of the path you are going to see. As it is moving here, if it is coming to this position, you will see the shadow of it coming to this region. If it is again moving in this direction, you will see the shadow of it coming to this position. Okay, if this is point A, this is your point A. If this is point B, this is your point B. If this is point C, this is your point C. If it is here, this will be point D. By the way, this is what we call it as phasor. Okay, phasor, the projection of object which is performing uniform circular motion, okay, of it will be doing a simple harmonic motion, or the shadow of an object which is performing uniform circular motion is doing SHM. You can analyze it in this way. Now from this you know that the shadow is covering how much angle for one complete cycle? It is covering 360 degrees. The angle covered by it is 360 degrees. It depends on, you know, the formula for omega is equal to theta by t. Can I write theta is equal to omega into t? Yes, obviously. So I can analyze the position of the object. Let's say if it is at this point, okay, that means if you are projecting it in upward direction, the position of that particle might be found in two different conditions. One is here and one is here. But which one will you be choosing? You will be deciding on direction. If it is going in this path, in this direction, that means it is the this is the direction in which it is actually moving from. Okay. Now, if the particle is here when it is going, you are going to take this as your second position. This will be the first position. I hope you are understanding how we are analyzing it with respect to this thing. Now, it might have covered an angle omega t, which can be written as theta. Now, this is the displacement. The distance from here to here, the distance from here to here is considered as the displacement of that particular particle, x. Okay, which can be written as, this is your x, which can be written as, if this is a, which is the total radius of that circular object which is performing circular motion, that is why it is becoming an amplitude. You can write, if this is omega t, this will be omega t minus pi by 2 minus omega t. You can write this line as pi by 2 minus omega t. Okay, so that makes it the value of x. If you are resolving into components, we are having this one as a, and if it is making an angle pi by 2 minus omega t, you can write this side as a cos pi by 2 minus omega t. So this can be further written in terms of a sine omega t plus or minus phi. So that is why we are getting an equation of SHM in this manner. Now further, if you are trying to analyze the equation of SHM, you can give the position of the SHM in any way. So now if it is at maximum extreme, you know, by if it is at location B, it would have covered the angle pi by 2. If it is at a location C, it would have covered the angle pi. If it is at location D, it would have covered angle 3 pi by 2. Okay, in the same way we can analyze depending on the angle, depending on the time. Okay, it is a function of time, since the object is actually moving with respect to time. With respect to time and angle, we are analyzing it. Okay, that is how we will do SHM. Now the general equation of SHM, if you are analyzing a little, you know, x is equal to a sine omega t plus or minus phi. Now what is this initial phase? If you are trying to analyze initial phase, it is not necessary when we are observing that object which is performing SHM, we see that object at the mean position. We might have seen that object at any other position. So to analyze this motion properly, we should be taking care of where we are actually observing the initial position of the particle as. If the initial position of the particle, okay, if initial position of particle is at mean position, then you can write x is equal to a sine omega t alone, because phi initial phase will be written as 0, will be taken as 0. So now if you are taking the time period, okay, the total time period to complete one cycle is capital T. In time period time, what is the displacement of the position, you can analyze. Okay, x is equal to a sine omega, general formula is 2 pi by t into capital T. So these two gets cancelled, you will be getting a sine 2 pi. What is the value of a sine 2 pi? It will be 0. That means object should have come to the mean position. In the same way, you can analyze for any particular time period, at any particular time, what is the position of the object, you can analyze. Given if there is initial phase, you will be adding that initial phase as well. Okay, so finally the equation of SHM can be written as a sine omega t plus or minus phi. If you are trying to find the velocity, velocity can be written as dx by dt. You can write it as d by dt of a sine omega t plus or minus phi. If you are differentiating this, since a is constant, I am bringing it outside. Okay, the remaining terms, which is the function of time sine omega t plus or minus phi, can be further written as the differentiation of sine will bring me cos omega t plus or minus phi. Further differentiating omega t plus phi will give out omega. So the velocity of the object will become a omega cos omega t plus or minus phi. This is the velocity of the object. If you are further trying to analyze the acceleration, acceleration is dv by dt. So if you are differentiating velocity with respect to time, a omega cos omega t plus or minus phi will be equal to a is constant, omega is constant, cos when you are differentiating you will get minus sine omega t plus or minus phi, and again if you are further differentiating this one, you will be giving out omega, it will be giving out omega. So further the equation of acceleration can be written as a omega square sine minus of a omega square sine omega t plus or minus phi. Now if you are observing it, this will be written as minus of omega square into a sine omega t plus or minus phi. This a sin omega t plus or minus phi can be further written as x itself minus of omega square into x. This is the initial equation of SHM that we have taken. Okay, this is a condition of SHM. That is the reason why the output is here a sin omega t. I hope you got this. Okay, now further if you want to analyze, you can use these formulas. You can use the formula of velocity. Okay, further velocity can be written as minus of, okay, you can write the velocity equation as, the equation that is given there is a omega cos omega t plus or minus phi. I can write this entire expression as, since we know an identity equation that is sine square theta plus cos square theta is equal to 1, I can write sine square theta is equal to 1 minus cos square theta, or cos square theta is equal to 1 minus sine square theta. So cos theta can be written as under root 1 minus sine square theta. So substituting that in this equation, I can write this one as a omega into under root of 1 minus sine square omega t plus or minus phi. So if I am sending the value of a inside, okay, now this is in the form of, we know what is sine omega t, x is equal to a sine omega t plus or minus phi. So from this equation, sine omega t plus or minus phi can be written as x by a. Substituting that in this equation, velocity will become a omega into under root of 1 minus x square by a square. So further if I am taking it, a omega into under root of a square minus x square divided by a, when the a is coming out of that root. Further you can write these two amplitudes get cancelled. Velocity can also be written as omega into under root of a square minus x square. So these are the different forms of velocities and accelerations that you can use. What is the maximum velocity? When do we have maximum velocity and when do we have maximum acceleration can be analyzed from this case. Minus omega square x. If your x is 0, that means velocity will be equal to under root of omega into a square. That means it will be giving you omega a, and moreover when you are applying this rule you will be getting it as plus or minus. Plus or minus, velocity can be either positive or negative, it depends in which direction the object is actually traveling in. Okay, now the where will be the maximum acceleration? When object is at maximum amplitude. Okay, so maximum, at the maximum, either at a negative extreme or at a positive extreme, you will get acceleration to be maximum. Okay, so where it will be minimum acceleration, will be minimum, which is equal to 0 at mean position. Okay, mean position. In this way we can analyze equation of SHM in different way. We can substitute the values, we can analyze what is the velocity of the object at different position at different time period. Okay, so I hope you understood this well. We'll meet in the next video. Thank you.